In this video, we're going to talk about a perfectly inelastic collision. This is going to be a collision that converts as much kinetic energy into other forms of energy as possible. Basically, our kinetic energy, 1/2 mv squared, as much of that as we can lose, we're going to. And the way we do that is by having two objects. Let's give a blue object, boop, doop, 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 and a red object, sheep-a-doop, dap. And those are going to collide. We're going to have those moving towards each other, and we'll give them different masses, different velocities, but afterwards they're going to stick together and they're going to slide together. And so because they stick together, they lose as much kinetic energy as possible. That kinetic energy is going to mostly go into deforming them to cause them to stick together. It takes a bit of energy. So let's go ahead and throw some numbers to these and see what this is going to look like. Let's give this a mass of, let's just say 5 kilograms, just to be nice and simple to start with. We'll give the red one a mass of 10 kilograms. So it'll be twice as large. But let's give the blue one a velocity of, let's say, 25 meters per second. Let's give the red one a velocity of 10 meters per second. So this shouldn't be too hard to solve because our momentum, our total momentum at the start, let's just say momentum not total, will have to be equal to our final momentum. So these two will have to be equal. So this will equal our final momentum. All right. Well, what's our initial momentum going to be? Well, it's going to be the momentum of both of these pieces. So it's going to be that momentum plus that momentum equal our total momentum. And so we can split this momentum into our mv plus mv will equal our final velocity. And that final velocity, the mass of that is going to be m plus m. So this is our general equation for solving perfectly inelastic collisions. If I put all my numbers in here, this is actually a pretty straightforward equation to solve. So the first mass would be 5 times 25 plus 10 times 10 equal the 5 kilograms plus the 10 kilograms, and that times v. 5 times 25 is going to be 125 plus 100 equal, and then 5 plus 10, that'll be 15v. And so on the left side, we'll have 225 equals 15v, and we can divide both sides by 15. Now 225 divided by 15 is actually 15 meters per second. That'll be our final velocity. So the velocity of this paired together will be 15 meters per second. Great. Now that's pretty straightforward, suspiciously so. Of course, it's going to get a little more complex than that. This is fairly simplistic to set up. We just need to remember that momentum is mv. But the challenge here is going to be that it's always mv. So we're going to end up with lots of m's and lots of v's in our momentum collision equations. So we're going to need to be able to stay organized. On top of that, we're going to combine this with other concepts. One type of problem we might encounter here is what's called a ballistics problem. And this is where we're going to have a bullet fired into ballistics gel in order to measure the velocity of that bullet. This is actually a pretty straightforward thing that can be done with really any kind of projectile. You could shoot a BB gun into a tin can that's on a string and then just figure out what height it goes up to. For this, we're going to say the initial velocity here, this guy's velocity is unknown. We're trying to find it. We're able to weigh the bullet beforehand. We're able to weigh it in order to figure it out. We're able to weigh the ballistics gel and weigh it after to figure out how much mass we have. So when we do that, we determine that the mass of the bullet is going to be 0.015 kilograms. So it's going to be 15 grams. And then the ballistics gel itself, we're going to give that a mass of, let's just say, 0.25 grams. So it'll be, or kilograms, so it'll be 250 grams. And it goes to a height, when it gets hit, it goes to a height of, we'll say, 0.75 meters, which is a pretty significant height. Now, we want to find the velocity here. So this is an experimental setup that we could create. We want to figure out this velocity. Well, this becomes an energy problem. We're going to have a height here, right? That means we're going to convert kinetic energy into potential energy. What kinetic energy are we going to have? We're going to have kinetic energy at this moment, right here, after the bullet strikes the mass. We're going to have some initial velocity. So the velocity, we're really going to have three velocities. We're going to have velocity of the bullet. We're going to have a velocity of the bullet and ballistics gel, let's say BB, and then we'll have a final velocity, which would be, over here, velocity at the final height, which would be 0. This velocity of the bullet and ballistics is going to be the final velocity for our momentum problem, but it's going to be the initial velocity for our energy problem. So this is what merges these two together. So that will get converted into a height. So we can work backwards from the height. So we're going to go set up kinetic energy equals potential energy, which is mgh equals 1/2 mv squared. Our masses drop out, we don't need them, and we get 1/2 v squared being equal to gh. And so once we plug our numbers in, this is actually pretty simple to solve. So we can hit that with a 2 and then take the square root of both sides, and we would get rid of our 1/2 and get rid of our square. And we would have our velocity being equal to 3.83 meters per second. So that's going to be our velocity of our ballistics gel and our bullet combined. So we can put that in right here. Let's say this is 3.83. And so now I can set up an inelastic collision. So here I'm going to have my mass times my velocity, wrong color. I have my mass times my velocity plus the mass times initial velocity, v naught, of this guy will be equal to the mass plus the mass of the ballistics gel plus the mass of the bullet times that final VBB, ballistics gel and bullet. So this guy, mv naught, that is 0 because the ballistics gel isn't moving before it gets struck. So all of this stuff is just going to be mv equals mass plus mass, which here is going to be 0.265. So let's just write that in, 0.265 VBB. And so we have these numbers, so we can plug those in. It's going to be 0.015 times velocity equals 0.265 times that final mass, which was 3.83. Not final mass, the final velocity, 3.83. So here on the right side, I get 1.015 equaling 0.015 times that initial velocity. Now I just divide both sides by that 0.015, and I end up with a velocity for my bullet of 67.7 meters per second. So that could be a little more challenging to set up, but the math still works out pretty quickly. The setup just requires us to remember our energy rules. So let's do one more version of this problem. In this one, I've got an arrow hitting an apple, which together they are going to form some projectile motion. We can use projectile motion to work backwards to solve for the initial velocity of that arrow just like what we did with the ballistics gel. The only difference is we're using projectile motion instead of energy. So let's give ourselves some data here. Let's say this pedestal is at a height, let's give it 0.5 meters. Let's say that apple and arrow combination lands 3 meters away from that pedestal. Now, we can set up a table just like we've done in the past. We've got an X and a Y. We've got a displacement. And so our change in X, we're going to start at 0. We're going to end at 3. Our change in Y, we're going to start at 0.5. We're going to end at 0. Our initial velocity in Y is going to be 0. We're not moving down before we leave that ledge. Our acceleration in Y is going to be negative 9.8. And our initial velocity in X is going to be what we're looking for. So I want to find that. I need to figure out the time in order to figure out my initial velocity. So if we set that up, we can just say for x naught, we can just say delta y. Delta y is going to be negative 5, negative 0.5, equals v naught t plus 1/2 a t squared. This should actually be g. If I plug my values in, this is going to go to 0, and I'm going to get 0.5, negative 0.5, equals 1/2 of negative 9.8 t squared. And so if I want to solve this, I just take negative 0.5 divided by negative 4.9 equals t squared. Take the square root of that, and I can solve for t. And I will get 0.319 seconds. So I plug that in right here, 0.319 seconds. And now I want to solve for my v in x. And so that is going to be found by the change in x is going to be equal to v naught t plus 1/2 a t squared. Well, this a right here, that would be 0. We're not going to accelerate in x at all. And so this goes to 0. That whole term drops to 0. And I got my change in x, which for this is going to be 3, equals v naught, which is what I'm looking for, times 0.319. So if I divide 3 by 0.319, I get my initial velocity when this left the pedestal. And that gets me 9.4. So 9.4 meters per second. Fantastic. So now I know my velocity right here, right when this left the table. That is 9.4 meters per second. What I'm looking for is the initial velocity of this arrow. So let's give this apple, let's give it a mass of, let's say m apple. The arrow is already ma. Let's say this is mp, and then the arrow is ma. And so the apple will have a mass of 0.2 kilograms. So it'll be 200 grams. That's not a terribly large apple, but it's still a pretty big apple. And the arrow will give 0.1 kilograms, a 100 gram arrow. So then we can solve this by saying VA times MA plus the apple times M apple will equal those masses combined, MA, MP, times velocity final. Well, this final velocity, that's this velocity right here. It's going to be the same number. I'm just using 2 different points in time. And so I can plug as many numbers as I can in here. Let's go ahead and do that. Let's do that off to the side here. I'm going to have VA being what I'm looking for, times 0.1, plus VP. Well, VP is going to be 0 because the apple is just sitting there before we hit it. So that whole term goes to 0. So that's just going to be equals, and then MA plus MP, which is going to be 0.1 plus 0.2, equals, and then that final velocity of 9.4. Great. So then I get 0.1 VA equals 0.1 plus 0.2 is 0.3 times 9.4, which gives me 2.82, 0.1 VA. So I can just divide this by 0.1, and I get a velocity for that arrow of 28.2 meters per second. There we go. So we can now see that we've got two different ways that we could figure out from a ballistics test what the initial velocity of a projectile could be, just by forcing it to undergo some kind of inelastic collision. So these can be very useful problems to be able to solve.